This is a SQL versus Mongo is the official title. I put SQL versus NoSQL primarily because last year I did a presentation, SQL versus NoSQL, where I looked at SQL Server and Mongo in depth, right? So how SQL uses tables, Mongo uses documents. We'll cover a little bit of that, but at last year's keynote, they mentioned that SQL Server was going to be a platform, right? And I know they extended that a little bit more this year as well. But they announced SQL having a poly-based connector into Mongo, and I thought, that seems like a logical follow-on to last year's presentation. So I took last year's presentation, and I just changed the verses and put an and in there, and I thought, oh, I'm all done. And then the other day, I was looking at it, and I realized, oh, my official title is SQL versus Mongo, so that's why you get this. And I will tell you that I use DocumentDB and Mongo interchangeably. You'll hear me sometimes say one, sometimes the other. If you're a Mongo person or a DocumentDB person, you realize that they really aren't interchangeable, but in terms of this discussion, they are. So if you hear that and you inwardly cringe, don't worry about it. Yes, I do know the difference, but again, for this discussion, it's good enough. So this presentation is really a discussion of working in SQL, right? It's targeted towards Microsoft SQL people, but looking at integrating Mongo data into SQL Server, okay? All right. Sorry, I had to wake up my clicker here. So you'll see these. I'll be the first one. I don't feel badly about telling you these because you haven't been into another session this year yet. If you need to take a cell phone call, by all means, take it out in the hallway, please, so you don't bother everybody else. PASS has a whole lot of stuff to offer, a lot of online, a lot of SQL Saturdays, free learning about SQL Server, fantastic opportunities there. And if you want to volunteer, there are options for that as well. So here's my contact information. Feel free to contact me. This Red Diamond Consulting is mine. And a slightly off topic, but I sometimes get asked, where did I come up with that name? Well, as you can guess, red is my favorite color. I drive a red vehicle. I love red. So I said, well, it has to have red in the name, right? And I was looking for something valuable, right? Diamonds are valuable. And so I looked it up, and sure enough, there are red diamonds. And they're both rare and valuable. And I said, that pretty much describes me. So there you go. I don't know how valuable, but certainly rare. All right, session evaluations. Again, these are really just for presenters to be able to get feedback from attendees and know what to improve and things like that. You can get it from the PASS app. You can go to passsummit.com and fill them out there. Have them done by Friday if you would. Or email me, catch me in the hall somewhere, tell me what you think, one way or the other. And a lot of people don't do this, but I put this up early because I realized there are a lot of places you could be other than here, and I appreciate you coming in and giving me someone to talk to, because I've given this presentation many times to myself, so it's nice to have someone here. So who am I? Really, I'm a DBA, production DBA, developer DBA. I've done a little bit of everything. At one time, I taught SQL, various things in SQL. I've been using it since 4.21a SQL Server. Does anybody know what the significance of that is? Other than that I'm old, yes, right. Yeah, thanks for that, by the way. Yeah, it's back when it was a SQL Server Sybase product, right? So back in the early 90s. It's a long time. And 4.21a is the one I first used. Yep. 3.6. Pre-6, yes, pre-6, yeah. Yeah, back when you dropped a database, you had to go in and delete the files. Anybody remember that? Right? So I've seen a bunch. And yes, this is the best picture I've seen of myself, so I put it up there for you. Okay, kind of who this is targeted to, folks that, 10 minutes ago I asked who's using Mongo, and 60% of you already have it installed in some degree. So you're interested in SQL Server, the ability from SQL Server to connect into Mongo, right? Or maybe you're just curious. You say, well, I don't think I have it used today, but I might tomorrow, or if I know, then I know when I can use it, right? All right, so I did get a couple of questions early on. Do I need to know Mongo to attend to this? And the answer is no. I'm not going to tell you how to set up Mongo. I'm not going to tell you in depth how to administer it, but I'll describe a little bit about the documents and how it stores data, okay? After that, we'll look at some key comparisons between SQL on the one hand and Mongo on the other, okay, in terms of when you'd want to use SQL and when you'd want to use Mongo. We'll look at some use cases of getting data between the two or using it between the two. And then kind of the heart of Polybase is this install, prepare, and query Polybase. And then I've got a catch-all category where anything I couldn't think of categorizing the other ones, I threw in there. And this is pretty informal. If you've got a question, by all means, just shout out or raise your hand in the middle, and I'll be happy to answer that. All right, so I mentioned earlier that I interchange DocumentDB and Mongo. It turns out DocumentDB has 4 different types. It's got like an HBase, it's got a graph type, it's got a DocumentDB type, and there's a 4th one, I can't remember what it is off the top of my head. But of the 4, DocumentD is by far the most common, and that's because it's used in a lot of websites. So the most common implementation of DocumentD is MongoDB. So all of my examples use MongoDB. However, MongoDB and Cosmos are both document database implementations. Cosmos, of course, being Microsoft's hosted version. And Cosmos is wire compatible with Mongo. And what that means is if you have a Mongo implementation, you've got some data, you can throw it up into Cosmos, just point your application up to Cosmos, and it works. So, anybody here using Cosmos? I expected a couple, but well, it's actually pretty cool, I have to say. So what is DocumentDB or Mongo? It's an unstructured data repository where you can store any JSON you want and retrieve it by ID, okay? So that's a really high level. Unstructured just means, unlike SQL, it doesn't have the constraints in terms of what my schema looks like. It's a repository, i.e. database, right? You can store any JSON, and again, I'll get into most of these here in a minute. JSON is just a document format, and retrieve it by ID. So it comes with a default ID, but of course, what database would be useful? I mean, how useful would it be if I can only retrieve it by ID, right? So, of course, you can retrieve it by other fields as well. This is my definition. It's really a database created by developers who didn't want the database to get in the way. So think back to SQL Server. If you're a developer, for example, and you want to store some data, what do you have to do? You have to get a hold of the crusty DBA, right? And you have to say, hey, I'm going to store some data. And I say, well, okay, great. Do you have a database name you want to put in, you want to create? Okay. What's your table name? No, I don't like that table name. We don't use those, right? All this kind of stuff. Eventually, we get down to fields and data types and all that. In the Mongo world, the developer says, I want to store some data. He creates a JSON string, sends it off to the Mongo engine. If it doesn't exist, Mongo creates it for him. So good and bad, right? The bad news is you're going to end up with a bunch of stuff in there that you as a DBA don't really understand and don't have any control over. So I'm going to give you examples based on a junkyard. Everybody knows what a junkyard is, I assume. It's a place where you take your car when it's worth more as parts than it is as a whole, right? I have to confess I've driven a few of those myself. And the reason I do that is because not only does it kind of fit the Mongo world where I don't necessarily know what data I'm going to store in there, right? I get a new car in. I don't know if it's going to have a steering wheel. I don't know if it's going to have a set of tires, and I can create a document that represents that car, regardless of what it looks like. The other reason is because you're all at least somewhat familiar with a junkyard, but you're not so familiar that you're going to start thinking, well, how would I design these tables? Because really, this is about concepts and techniques. It's not so much about the specific fields you're going to store in there, right? I mean, we're all data people. The minute somebody starts talking about something, we're, oh man, I would design it like this, and I'd create a constraint over there, right? This is a little higher level. I don't care so much about that. All right, so this is pretty familiar to all of us, I assume. This is what I would design if I was working in the SQL world. I'd create the top table is the car table, and I've highlighted it as yellow or blue, depending on which vehicle, right? And then I've got a related table. It's a relational database, right? So I've got a related table, and that related table, in this case, I just called parts, and the yellow ones belong to the yellow car, and the blue ones belong to the blue car. All right. That's about as much as you guys really need to know, and I've covered it already. So to make it useful, let's say I want to display a particular car on a screen, I'd have to do a join, right? We get a lot of joins in SQL because we have all this related data that has to be joined to make it actually useful. In the document DB world, Mongo in particular, or Cosmos, we have, on the right-hand side, we have these documents. And a document is self-contained. So if you look at the top one, right, this one here, and mind you, these are two separate documents. So think of these as rows in a table. The top one has ID, model, year, and color, some basic attributes about a car. And the parts are stored as an embedded object within that document, right? So this is the basic structure or basic look of a JSON document. Now I've formatted it, it's got nice spaces and everything's lined up, right? Not how you usually see it. They're all just jammed together in one big line. But there are tools that will format it for you like that. And if you look at that, you'll see the documents on the right, the yellow one corresponds to the yellow in the SQL table, okay? One thing I did want to point out, if you look at the parts, you'll see we've got engine and racing stripe, and then seat, transmission, and engine in the bottom one, right? Notice that they're different. So those are kind of like fields in a table, but they don't have to be the same. And there are cases where that makes a lot of sense and cases where it doesn't. We'll look at that a little bit. All right, so I mentioned NoSQL as a repository. Again, just a database. High-level Mongo terms, they do organize things into databases just like SQL does. I'm going to use Tucson as my database name, primarily because when I first came up with this, I was in Tucson at the time, and that seemed like a great place to start. So if I was creating a junkyard, let's say I decided to start up a junkyard in Tucson, I would create one for there. And let's say I wanted to expand to Phoenix, I might create a database for Phoenix, right? Again, this is just logical organization. So within the database in Mongo, you've got collections. So I'm going to use collections of Yugo, Beetle, trucks, sports cars. Again, this is just an organizational structure. You can set it up however you want. But again, flexible data storage, we looked at the one earlier where the parts were different depending on which document you were looking at. It doesn't have to be the same. Of course, that cuts both ways, doesn't it? Right? If I pick up a record and it has a steering wheel in it in one record or one document, and I pick up the next document, it doesn't have a steering wheel, and I'm displaying this on a web page, I have to deal with that, right? I've got to somehow be able to say, well, I'm expecting a windshield, for example, to display on my screen, right? So the flexibility introduces complexity as well, okay? I threw a filing cabinet up there primarily because I'm a little bit old school this way. I like to give analogies. In the SQL world, if I had a filing cabinet, it would be like being at an insurance company, right? I'd open that file, and it would be, let's say, car insurance. Every single folder would be a different car insurance file, right? So the first one might have Joe Smith, the second one is Betty Sue something or other, right? But they'd all have the same basic structure. In the document DB world, it's more like a filing cabinet at my house. I might have home warranties in the first file. I might have insurance documents in the second file. I might have just miscellaneous in the third file. And I pick them up, and I don't know what's in it really until I pick it up and I look in it. Again, sometimes you're going to have to work with that, the fact that they can be different. So consistency is not required, and the hierarchical structure is just what we looked at earlier, where we've got, in the SQL world, we have to pull it apart and put it in different tables. In the Mongo/DocumentDB world, I can put all of that into one document. So it stores its data as JSON. We looked at that a minute ago with all the curly braces, the commas, all that fun stuff. You get used to it, and it's not bad. The reason it was created was because JSON is native to JavaScript libraries. So JSON, JavaScript, object notation. And this was originally developed for web-based applications, right? So if I'm displaying, let's say I've got a junkyard screen up and I've got a car, well, I can take everything on that screen, put it into one document, store it in the database. And conversely, when I pull it from the database, I pull a document, display it, bring it into an object in JavaScript, and display it on the screen. So same language, same techniques all the way through. As opposed to SQL, right? We've got T-SQL to store our data, we've got JavaScript in the front end, we've got HTML, we've got all kinds of stuff. And then it's a smaller footprint than XML. Again, this was developed probably 10 or 15 years ago. In my experience, XML is about 30% larger than JavaScript, than JSON. And this becomes really critical when you're dealing with mobile applications or web applications, right? Where the bandwidth, the pipe is much smaller. And I mentioned this earlier, there's no shredding or joins. So if I'm pulling the data out of the database, I don't have to join it all together in order to display it on a screen. And again, conversely, I don't have to, when somebody enters information about a car on my junkyard website, I don't have to shred that and put it all into separate tables. All right, some other differences. SQL, again, normalized. We don't want to duplicate data. Very tabular, structured format, so it's predefined, right? You've got to go to your crusty DBA and get your table defined for you. And we use nulls if there's no data. What do we know about these nulls? Sorry? They take up space, okay, that's true. We know the column name, right? Even though I have no data there, I know what type of, or what the name of the data would be, and I know the data type. So I know a little bit about them. In NoSQL, as opposed to SQL, we're going to have denormalized, which means we're going to have a lot of data duplicated, right? And again, we can store it hierarchically, so I can take all this hierarchical information and drop it into one document. This document, for the most part, will be self-contained, so I pull up a document and it's going to have everything I need to know. I'm not going to have to go to another table and get lookup information, right, where we have to do these joins to find out some label or data type. And there's no set schema, which I mentioned before. And missing data is just missing, right? So if I pull up a document, it's self-contained, I look at that one document, do I know that another document has a racing stripe? I would have no idea, right? A couple more differences. SQL uses the ACID, not sure what I would call this, atomicity, consistency, isolation, and durability. We're all pretty familiar with this, right? Either your transaction completes or it doesn't. It's consistent after a transaction. The transactions are isolated from each other, and they're durable, so I get no loss of data after a failure. Okay, pretty familiar with that. NoSQL, DocumentDB, doesn't have that same concept. It has a concept called CAP. So consistency, availability, and partition tolerance, right? So consistency just means all connections see the same data. Availability, you're always going to get a response. And then finally, partition tolerance, just that a network failure is tolerated. So unlike SQL, which really started out as a single database, like a desktop kind of application way back when, and has morphed into something much, much larger, NoSQL or MongoDB was really designed as something that could be distributed horizontally. So it's got sharding in it, built in. So the only caveat here is you get to choose two. You don't get all three of them. Right. All right, some use cases. I might have SQL Server and I might have Mongo, and I use them more or less independently. I might take some SQL data and pull it into Mongo, the other way around, or I might use them together. We'll look at those here. So if they're independent, it might be related data, but not necessarily dependent. Okay? So in my junkyard example, I like to use SQL, which is really good at financial transactions, right? So I might have my accounting systems. There are all sorts of SQL-based accounting systems. I've got all my financial data in SQL, and I've got my inventory in Mongo, right? So if I sell a car, I can put some information into my accounting system that I've sold this car, but there may not be a direct connection between them, again, depending on what you want to do. So you can store your Mongo document and ID in SQL, and then query the SQL and go get the Mongo document. One use case, you could update web catalogs with this, right? So if I keep my price list, for example, in my accounting system, but my inventory in Mongo, so I start my junkyard in Tucson, and I realize that I'm dealing in classic cars. Well, classic cars, there's an interest in those all over the world. So I might want to make my price list and all my inventory available, not just in the US, but in every country. So I would take my catalog, throw it into Mongo in a whole bunch of different web farms. And the nice thing about that is there's no licensing, right? I might use it for data exchange or archiving. And again, it's a self-documenting universal format. Getting SQL to Mongo, this talk isn't specifically about that, but I'll show you a little bit about how to do that or ways you can do that. You can use PowerShell, C#, if you're a developer type, SSIS, there are drivers for Mongo, or you could use a link server, right? Now this is kind of the heart of this discussion. So I want to get Mongo data and use it inside of SQL. I might use it for BI reporting because SQL's got Power BI. It's got some other great BI tools, right? I might want to merge my data. So again, I've got financial data in SQL, and I've got my inventory in Mongo. I might want to have a dashboard that shows me my current inventory levels along with what they're worth, or my sales, right, and what I've sold. So I could use Polybase to do that. I might want to capture the data now and analyze it later. So SQL Server is good at capturing data. However, pretty much everything is logged in SQL. So if I'm going to dump a whole bunch of stuff in there quickly, Mongo's actually better at that because it has less locking. So I could capture it now, analyze it later. And the great thing about this is I can use T-SQL syntax to analyze it, right? I can use my Power BI tools. I can do all that kind of stuff. And we'll look at that in a minute. And then bidirectional is just going to be a combination of the two, right? All right, so here we get to the core of the presentation. So again, I mentioned that last year they announced SQL as a platform, and they announced Polybase Mongo connector, which is available in 2019 and later. Okay, now it's generally available, so you can use it in your production systems. It is a SQL feature, which just means you can use it or not use it, right? Kind of like SSIS or SSRS, that kind of thing. And it runs on Windows and Linux. And I'll tell you, the Linux piece is really an exercise for the reader because I've not tried that. Anybody here tried that using Polybase on Linux? Okay. Documentation says it works, so I assume it works the same. Okay, so I've decided I want to use Polybase. What do I do? First of all, when you install SQL, you see this Polybase here, the query service and the data connector, Java connector for HDFS. You need to select those two items. Okay. You can use Polybase as a standalone, or you can set it up as a scale-out Polybase, which just means that there's one server that controls other Polybase servers connecting to Mongo. So if I had 100 Mongo databases, I could have 100 SQL Server Polybase servers distributing the queries out. And here, so the Polybase engine for Mongo uses either the Java runtime environment or the Java development kit. You have to have one or the other. It will install the Java runtime environment if you don't have one already. In this case, it's using 11.03, but again, this is release candidate 1, so that might be different. But you can also specify your own if you want. You get two new services, the Polybase engine and the Polybase data movement service. Okay, pretty straightforward. All right, now here's where the magic starts, right? So before I can start connecting to Polybase or connecting to Mongo using Polybase, I need to do a couple of things. And these are color-coded for a specific reason. The top one is instance-wide. So I have to enable Polybase. Okay? That's pretty straightforward. It's an SP configure, enable Polybase, and reconfigure, right? No restart required. The second two, or the second and third one, are done once per database. So I create a master key, and this master key is what's going to be used to encrypt the credential. Okay? So I create a master key, encryption by password, and this is once per database, right? So again, this is going to be used to encrypt the credential. So the third step is for the create credential. I call mine Mongo user, right? And you give it an identity and a password, and this identity and password is what's going to get passed to Mongo. So it's a username and a password that has to exist inside of Mongo. And then finally, you define the external data source. And this is just really telling SQL Server, whenever I reference this Mongo data, where do I go to get it? Okay. So again, I'm calling it Mongo Tucson. Very clever, I thought. MongoDB. This MongoDB is the same whether I connect to Mongo or to Cosmos. All it's really doing is telling SQL which libraries, if you will, to use, right? And then the 127.0.0.1, that's localhost. So in this particular case, I happen to have Mongo on my local machine, but it might be sitting externally somewhere, right? So I just give it an IP address. And I give it a credential. I tell it to use that credential. And this is this SSL equals false is only if you're going to connect to a local Mongo and you don't want to use SSL, right? In my case, I didn't want to because it's on my machine. I don't really care. Okay, so now we're ready to use it. So next thing we have to do is create an external table. And an external table is really, think of it as a mapping or a view into the Mongo data, okay? So again, SQL is very structured, but Mongo isn't. So we have to tell it when I go grab this data from Mongo, what can I expect to be there, right? There's one or more per collection. And remember, we have, in the Mongo world, we've got databases, and then within the database, we have multiple collections, and then within the collections, we have documents. So you can have, you create an external table, one or more external tables per collection, but they can't span collections. And this one's really critical, and this is, I think, is one of the biggest things in the SQL as a platform concept is the data isn't copied to SQL, right? It's not an ETL process. We're not taking our Mongo data and pulling it into SQL and then working with it. We're just referencing external data. Now, the way SQL works, it has to get data from disk, and it's got to pull it into memory in order to use it, right? So it does have to do that. It has to pull it from disk, in this case, is Mongo or Cosmos, right? But again, we're not keeping it permanently in SQL. All right, so what does this look like to create a table? Well, this is a standard table, right? Create table, we give it a table name, we give it some fields. That would create a local table inside of SQL Server. And why did my clicker quit working here? If I'm creating a poly-based table, I say create external table, and then I give it this with location. So in the location, this thing just quit working entirely. Sorry, one moment. There we go. The location, this Tucson.beetles, is the Mongo database and collection. Your question?
Yeah, this user that you're creating in Mongo has to have the rights to create tables, read write.
Does the user that you're creating in Mongo have to have the rights to create tables and read data? It does have to have the ability to read data, for sure, not create tables. No, you spoiled something I was going to do later.
Predefining the table, right?
What is?
Predefining the table, right?
You're predefining, the question is, are you predefining the?
You wouldn't need the Mongo user to create the table. You're creating the external table in the engine so that you can read that data.
I think I understand what your question is. This syntax is done inside of SQL, so you are not creating the Mongo table here. You're creating a definition of a table inside of SQL that references an existing Mongo table. Is that right? And the collection is still in Mongo, correct? Yes. Yeah. You're materializing it, yeah, creating a view, if you will. But the difference between materializing is that actually creates a physical table in SQL. This is a virtual table in SQL, right? Question in the back?
For performance, do you need to actually define the data type? Does it always, do you have to have it specific, or could it just be nvarchar max? Where does that performance?
So the question is, couldn't you just define tables with kind of generic data types of nvarchar max, right? And then work with those. And the answer is no, you can't. You have to, in fact, give it the data type that SQL Server queries and gets back from Mongo. And I'll show you in a demo here in a few minutes what SQL's actually doing is going out to Mongo saying, I'm going to create a table that looks like this. Do you have data that matches this? And if the answer is yes, you're allowed to create the table. If the answer is no, you can't create this external table within SQL. You'll see in a minute. And if I don't answer in the demo, then let me know. So again, we've got the location is the Mongo database and the Mongo collection, and the data source is the one we defined earlier. So once I've created this external table in 2019, you may have gone in and seen this already. You get external table definitions. And of course, if this shows up in Management Studio, it means it's got to exist somewhere in a system table, right? So if I query sysobjects, I see that it's a type of U, which is a table, and ET, which is not our friendly alien, but external table. All right, so looking at simple documents, in this case, these are three separate documents. I show them together, but they're really not the same document. So the top one is just this document. Then you've got the middle one and the bottom one. And these all have the same columns or fields, if you will, right? So we'll look at a demo here. This is a simple document, so I picked a car that was simple and a Yugo, if any of you remember those from the early 90s, about as simple as you could get. We'll look at fields. We'll look at whether it happens on the Mongo side or the SQL side. case sensitivity, and then I threw in a common table expression as well. Okay, so make sure I'm the right one. Okay, so on the left, we see our documents, right? And again, this is really simple. This is using Mongo almost like a SQL database, right? So we've got 4 columns. They're all the same. I would create this external table. It's got 4 columns in it. I give it the location, which again is the collection, database and collection name, and the data source. And I've got the question at the top, auto schema detection. So what SQL does is I take this inside of SQL, and it passes it to the external data source and says, do you have this? And the answer is no, because I got an error, right? So I tried to take this error and put it all into a screen so you could actually see it, and I wasn't very good at it. But I also didn't look at that first. So the first error that I zeroed in on was that the data type for year was incorrect. Okay? Notice that it said year float of 53, and I have it defined as an nvarchar max. So I changed it to a float, and here you see my excellent typing. You'd think that I'd have better typing than that, but I don't. So it passed that in, even though it auto-detected it, it said, no, I don't have anything called year with a capital, but I do have something with year with a lowercase. So if I go and change year to lowercase, because remember, Mongo is case sensitive, right? So it passes it to Mongo. Mongo says, sorry, you're close, but you're not quite there. I fixed that, and now, there we go. I fixed that, and now I'm able to go create the table, right? So unlike SQL, right, where SQL is, SQL will allow you to create a table that it does, what's the word I'm looking for, late binding. I guess that's not really the right term, but. I'm sorry? Why is underscore ID data type nvarchar? Because that's what Mongo told SQL it was looking for, right? So, yeah. The question is, if I define this table missing a column, what happens? That's okay. I can skip things, and I actually do a demo where I do that, but you can skip columns. You don't have to have them all. Okay, so I created the table, the external table. Let's query it and see what it looks like. In this case, it's going to be pretty straightforward, right? I mean, I just have essentially a SQL table. So I select star, and I get what I expect, right? Rows and columns. Okay, no problem. Now, the other thing I wanted to mention is that there's a difference between whether the query happens on the SQL side or it happens on the Mongo side, right? So if I make a query to Mongo and I get data back, once the data's back in SQL, in memory, I can treat it just like any other table, right? Because I already know what it looks like, so I can create this calculated field, right? And I've got a silly example here where I'm adding the year and the model together, but it could be really anything. Again, once it's inside of SQL, it behaves just like any other SQL table. Okay, again, I did a calculated field, but it could have been anything, right? It could have been group bys, anything like that. Now, the other thing to note, again, this goes to where this is happening, this case sensitivity. So I got the data back, and even though Unix is case sensitive or Linux is case sensitive, and notice the data at the bottom is lowercase, but my query was looking for an uppercase, that's because the data was already in SQL, right? So now SQL rules apply to what happens to that data. So when I do a where, it's case insensitive because, again, it's happening inside the SQL engine. All right. Yeah.
What is the execution plan for something like that? Is the query engine just doing all execution?
So what does the execution plan look like? I don't really know. I didn't do it. But exercise for the reader. Now that the general availability is here, you can go play with that. That's probably the next thing I'll do. That's with this. So this is curious, right? You see this select color, blah, blah, blah. That's exactly what I executed before. But when I put it in the CTE, it doesn't return me any data, which I think is a bug. But again, this is release candidate 1, so maybe it works. Okay. However, when I changed it to be the correct case, then it worked fine. Okay, so that's for a simple document. So if you want to take SQL stuff and move it into to store the data in Mongo, hey, there's your answer. So we've got an embedded document, and this is, notice that parts in this case, in a SQL world, that would be a related table, right? And this parts has a curly brace in front of it and a curly brace at the end, meaning it's a collection of name value pairs. And it can be a complex object, but in this case it's not. So I've got seat, transmission, color in both cases, but I also have this accessories at the bottom, right? That doesn't exist in the top record. So how do we handle that? So this is embedded. There's a kind of an unusual syntax here. So this demo, I called it Beatles because it's a little bit Volkswagen Beetle, of course, not the band. It's a little bit more complicated than Yugo's, but not terribly complicated, right? So we'll look at mismatched fields like that, accessories. We'll look at flattening. How do we deal with these things that are nested, right? And then additional external tables. There was a question earlier. And then finally, multiple nested tables. Wrong one. All right, so this one's a little more complicated. We've got nested data. So in this case, we've got seat, transmission, color in all three, but accessories in the third one. And again, just highlighting what they are. So this is mismatched. This accessories only exists in one, right? So this definition looks a little bit different. Again, same data source. The database is Tucson. The collection is Beatles. Take a look at this part, though. Notice this parts underscore seat, parts transmission, parts color. So we've got the container, if you will, and then the actual fields we want underneath it, right? So we create this. Okay, no problem. And the next thing is the flattened version of it. This is what Microsoft calls flattening it. And all that means is it's taking this data that's hierarchical or child to the parent and putting it all in a SQL format. You remember earlier I was talking about nulls versus not having data in Mongo? Well, now we have a null. So it took our Mongo missing data and turned it into a null. So, okay. But again, once it's inside of SQL, it behaves just like SQL data. Yeah.
So all you have to do is put that underscore in there, and that automatically knows to flatten it.
The question is, if you put the underscore in there, does it automatically know to flatten it? And the answer is yes. You have to give it the parent object name and then underscore and then whatever the child key is, and then it flattens it for you, yeah.
So if you had another document embedded under parts,
Great question. I'll show you that in just a moment. If the question is if you have multiple nesting levels, okay? So all this shows is that I can use ands and ors and all that kind of fun stuff once I've got the data inside of SQL, right? Or, yeah, once the data is logically inside of SQL. And there was a question earlier about, can I create another table, right? Or what if I miss fields? And here's an example. So in this case, there's a whole bunch of data in there, but I only want the ID, the model, and the year, right? So this is like a view, right? The document has a whole bunch more information in it, but I don't care about all that other stuff. I just want these three. Well, there is a performance question that happens here. So the way DocumentDB works is in order to get this ID, model, and year from each document, it has to pick up the entire document and parse through it. It's only returning those three fields, but it still has to pick up that entire document. Now, I suppose the positive side of that is you're only transferring those three fields across the wire, or however far that is. So you do get some benefit there, but still, that's just the nature of DocumentDB. It's not as efficient if I'm looking for subsets of data as SQL is. Again, because I've got to pick up entire documents at a time and parse them. So we'll just do a quick select. Again, it just grabs the three fields. Even though there's a whole bunch of data in there, I'm only getting those three fields. And then it turns out that I just have an extra external table defined. Right? Again, very much like a view.
If you query the same Mongo data over and over,
Yeah.
does that data land in the SQL buffer cache, or is it completely new query every time?
The question is, if I query it over and over, does it end up in the SQL data cache? I don't know. Exercise for the reader. Another great question. I wish I had an answer for you, but okay. So there was a question earlier. If we have multiple nested levels, so I've got parts inside of parts. I've got engine inside of engine. I've got belts, right? So and I did this intentionally just to make it a little more complicated. So what do you think this is going to look like? Yeah, you guessed it, right? So I've got parts underscore, and then I've got the child object, and because it's a parent, I have another underscore and the child, right? So I end up with parts underscore engine underscore belts underscore fan, right? You can see that this could get fairly complicated quickly. But it will flatten it for you, right? So again, I think it's pretty clever, actually, of the way Microsoft's done this. I mean, it needs to work with the data in the format SQL understands, and this is how they decided to make that work. Now notice all the nulls, right? Because not everything has all those extra parts in it. So we've looked at nested documents. We'll look at arrays here in just a second. Okay, so that's embedded. Arrays are a little bit different. They don't look different when you just look at them, right? Unless you're a JSON expert, and you know to look right in the middle there. You see that square bracket? That means I've got an array of objects. So arrays are typically used for iterating in the DocumentDB world. Notice I've got completely different things, bucket seed, bench seed. But I also don't have key value pairs. I just have values. So there's another difference. OK, so we'll look at an array. We'll look at using like, and we'll pivot this data. And then finally, we'll do a group by here. OK, again, similar data, except that in this case, I'm using an array. Okay. So I've got parts, and I've got the bracket, and I've got array elements inside of there. So how does this look different? I create the external table. What do you see that's different in there? Yeah, see, we've got the table name and then an underscore. So that tells me that it's an array. So when we select from this, this is also a little bit different, right? So I only have 2 documents, but I end up with 5 elements, right? So notice how it's treating embedded versus array elements differently. So embedded elements are getting pivoted up as new columns, right? And array elements are just becoming new rows in the table. And I guess you could argue whether it's a good thing or bad, but that's just the way it is. I guess that kind of makes sense.
It seems almost a little bit useless unless you could designate a separator.
You don't like the underscore as a separator?
No, I'm talking about in the column. So when you get it back, so you have bench C, 6-foot extended bed, that comes back as all bench C, 6-foot extended bed, all in the column, right?
Yeah.
Without any separator, without any way of being able to tell in the return data where each element begins and ends.
Well, I guess I'm not following you there, but. So bench seat is one element in the document.
Right. Oh, is it?
Yeah, it's one element.
Okay, I misread that. I thought when it returned trucks underscore parts, it was returning all of it in one row.
Oh, you were thinking it was pivoting it. No, it doesn't. That's one element. So trucks underscore parts is an array, and we know that because it's got the name of the table in it as the first part of the column name. And bucket seed is just one element from one document. And bench seed is one element from a different document. So we can use like. Again, once this comes into SQL, once the data is read from Mongo and is in SQL, we can do anything that we do in SQL, right, using like. That gets much uglier if you're working in the JavaScript side of things. And this I thought was just kind of fun. This string underscore ag is a 2017 construct, and you can take this and really just pivot your data around if you wanted. So in this case, what I've done is I've pivoted the rows, the array rows, and I've put them into one column. This is what you were thinking of earlier, I think, yeah. But I specifically did this, but. All right, so again, I can do things like group bys, sorts, orders, all that kind of stuff. So this is data from Mongo I'm treating just like SQL data, right? Group by, sums, that kind of thing. There's one more that's really cool. I'll show you in here in just a second. So now I've got a compound document. In this case, I have both an array and an embedded document, right? Because this is a little more typical, right? And they're not going to be all very, very simple. So provenance, if you're not familiar with cars, just means this part here just means where the car came from. And for your average Volkswagen Beetle, it's not such a big deal. But if you're buying a car that Johnny Cash owned, it goes up in value because Johnny owned it, that kind of thing. Okay. So we'll look at an array and a collection and a pivot. And that one was sports cars. Okay, so this is a little more complicated. I've got parts, it's an array, and then I've got provenance, which is an embedded document. So again, parts, what is that going to look like? Parts underscore engine, parts underscore body, right? And provenance is going to be, it's going to be sports cars underscore, right? So let's stop and take a look at that real quickly. So notice that we've got them both together. In the one case, we have the parent and then the underscore and the parts, right? Or sorry, provenance. Provenance underscore yearbot, provenance underscore owner. And then in the other case, we have the table name as the first element, then the underscore, right? And since it has the table name first, we know that that's an array. And it turns out if your array happens to be embedded even lower down, you still are going to have the table name in there, okay? So in one case, we pivot. In the other case, we just create additional rows. And again, just like in all these, the data types have to match. So the interesting thing is when we get to the Cosmos one, the data types don't come back as the same data types. So notice here we have 9 rows, even though we only have 3 documents. That's because of our array elements, right?
Question.
Yeah.
Is it possible to define things so that you have essentially 2 external tables mapped from the same document, one of them being the vehicle and one of them being parts of the vehicle? Kind of normalized thing?
Oh, could you create external tables, one that represents the parent and one that represents the child?
Right.
Sure. What advantage would you get? Because remember that for each one, when you pulled the document for the parent, you'd have to pull the entire document. So you're pulling the child information and then ignoring it. And then when you pull the child table, you'd have to pull the parent information and then just ignore it. So you're doing twice as much work. But could you? Yeah. Yeah. All right, so here we get the array data. Now, again, this is the array data, so we get 9 fields, right? Or 9 rows, right? Because, again, it turns array data into rows. And when we get the nested property data, how many rows are we going to get? 3, right? Because it pivots the information off to the right into new columns.
Can you create indexes on external data?
Can you create indexes on external tables? Not within SQL, no. Because remember, SQL is just taking the request for data, sending it off to Mongo. Mongo is returning the data using its indexes. And then once it's in SQL, then it's basically in memory. So here I just did the same thing as before with this string aggregate and a group by, right? Okay.
So on that
yeah.
index thing, then, when you have a where clause, so earlier you showed where it was case insensitive, right?
Yeah.
That thing is retrieving everything and then filtering in SQL, or did it actually pass it over to Mongo and ask it to filter?
If you're using a where clause in the SQL command and passing it to Mongo, does it do the filtering on the SQL side? Does it pull all the data back and do the filtering in SQL, or does it pass the where clause to Mongo? I don't actually know. I didn't know how I could test that out. I think there's a way, but I didn't have enough records to know for sure. So.
And then one final question on the data
Yep.
type thing, right? Maybe this is a Mongo question.
Okay.
When you specify year and then you put in a normal year, if somebody passes in a document that has a year that's maybe all spelled out, right? What does Mongo do, or how does it deal with that?
So so the question is, if I've defined year as int, for example, and somebody put a year in there in quotes and it becomes a string, what happens is that your query won't complete. So if it gets data that doesn't match the data type, you get an error.
So if you define an external table on a certain data type, and then later somebody puts something in there that doesn't match, you're going to get an error.
Yeah, the question is if you have a certain definition and somebody adds a new document or changes a document so that the data types don't match, yes, you'll get an error. Yeah. Yeah, so you remember earlier I said how flexible it is? So it's good and bad, right? I mean, if the flexibility is nice because I can do on-the-fly data changes, right? I could change the data type of a table one record at a time over time. But the bad news is for things like this, that causes you a problem, absolutely. Yeah, and I ran into that problem myself when I was testing it. Yeah, just the way it is. Okay, so I mentioned earlier that you might want to join the data together so that I can have my financial data and my inventory data together, right, on one screen. So I'll do a demo here in just a second where I'm combining the two together. You had a question?
Kind of expanding on his question.
Oh, can you pre-read the contents of the Mongo to create your external table definition? No. Not yet, yeah. Maybe some point, yeah. All right, so let's go look at that one. So this one I think is really kind of interesting, primarily because I can join the data together, right? So if I was running a junkyard, for example, I could create, in this case, I created a local table called parts costs so that I can have my pseudo financial data in SQL. So here's what the two look like separately. And I'll join the data. So look at this join here. So sports cars is my Mongo data. I'm just doing a left outer join with my parts cost, which is my local table. Okay. And so notice that I've got both SQL data on the left and Mongo data on the right. And I can do, again, I can do all kinds of things like if I was doing a dashboard, I could have information about my inventory and how much it's worth, right? I could do this for sales. I could do this for all sorts of things. So document modify, and somebody spoiled my surprise already, but so create, update, and delete, unfortunately, is not possible. It's just one of the limitations of Polybase. Polybase isn't designed to take your SQL data and write it into Mongo. It's really designed to take your Mongo data, read it in, and use it as part of your SQL. You're going to want to have a single point of truth. Anytime you've got multiple copies of data, and remember one of the earlier discussions was that with SQL it's normalized and Mongo is denormalized, you're going to have all sorts of copies of data. You will get duplicate data at some point. And of course that's supported by all the comparison and synchronization tools that are out there. So just identify which piece is your point of truth and use it. And I'm sure some of you are thinking to yourselves, well, this seems like a lot of work to connect to Mongo when I could just use a link server. Okay? I suppose there's some truth to that. But each has its strengths and weaknesses, right? So first is scope. A link server is for the entire instance, where Polybase is based at the database level, which means it is availability group aware, right? Of course, that means for each replica in your availability group, you've got to have the Polybase piece set up ahead of time, but it does fail over with it. Security, link server understands Active Directory, of course, with SQL. Polybase is simple. Remember, we had the username and the password that we passed to the external data source. This one's actually fairly significant. Link servers are single-threaded. So if I'm one of the selling points of Mongo, if you will, since it's free, is that you could store a whole bunch of data. You know, I might have a whole bunch of databases around the world. Well, if I do a link server query and I'm querying from a bunch of Polybase Mongo databases, that's all on a single thread, where in Polybase it's multi-threaded. Not only that, but I can use Polybase scale out, right? So I can do a whole bunch of Polybase stuff at the same time. Read-write, link server gets the nod there because it can write. I say Microsoft support no for link servers, and I know somebody's going to say, link servers are supported by Microsoft. Yes, they are. But Microsoft does not supply the drivers, to get a third-party driver from that, right? Where in Polybase it is all Microsoft. You can use PowerShell to read and write between the two. I use this module called MDC. I imagine there are others out there, but that one seemed to work pretty well. There's an example at that link. And let me show you a quick demo of PowerShell SQL, getting SQL to Mongo. And when I say quick, this may be the world's shortest demo. Okay, so this one is pretty straightforward. I installed the module. I've got, right here, I've got some SQL where I'm reading from SQL. And then I've got a loop down at the bottom, a for each loop. And I'm taking that data and just writing it into a Mongo database. So again, this isn't a PowerShell demo, so I didn't go into a lot of depth. But all it's doing is walking through the records from the SQL, writing a document for each one of those. It's really straightforward. So if you have the need to get your data from SQL to Mongo, it's pretty straightforward. And then we got some other things, right? A few other things. And of course, no talk is complete at a Microsoft-centric event unless we talk about something related to Azure. So, and remember I told you earlier that Cosmos is wire compatible with Mongo. So what I did is I connected Polybase to Cosmos. So you need 4 pieces of information from your portal. You need the host, the port, the username, and the password. So that seems pretty straightforward. And again, this is a screenshot from the Azure portal with Cosmos. You're going to have to create your credential, throw in those 4 pieces of information that I've highlighted in red there. And 2 things I want to point out. One, notice that it still says MongoDB, even though it's Cosmos, right? Again, Mongo just tells SQL that you're using the JDK or the JRE. That's all it really does. And you give it this host name and the port number, okay? And the other thing I want to point out is that I don't have that SSL equals false, right? Because this is Cosmos, so Cosmos is. All right, and I'll show you that. I was actually surprised at how simple it was. So I create my database scope credential. Okay, and don't worry, there's not enough of the secret there for you to use it. Even if there was, I don't really care. So I create my external table. It looks exactly like what I did with all the Mongo stuff, right? Now when I run it, the only difference is it takes a little longer, right? Because it has to go out to Cosmos, come back. Yeah, and the year was a different data type. Remember in the Mongo, it was a float, right? Here it's an int. And I'm not sure, I mean, the whole wire compatible thing, I'm not sure how that plays into it, but, and again, it takes a little bit longer to get my data back, but it does eventually come back. So you can run this the same, pretty much everything I've told you connecting to Mongo applies connecting to Cosmos. So there you go. And with that, that's all I have to show you. I want to say thank you for coming here. I appreciate you showing up. And if you have any questions, I'll be around.